Let's get started on Module 10, Resource Management and Monitoring, Part 1. In Module 10, we will discuss virtual CPU and memory concepts, resource controls, resource pools, memory resource usage, and using alarms. Let's start out with Lesson 1, Virtual CPU and Memory Concepts. There are 3 layers of memory in the virtual environment. You have the physical layer, which is on the ESXi host, and that's physical RAM. And then the ESXi host presents a portion of that physical RAM to the guest operating system, which is installed, and the guest operating system presents RAM to the applications that run on the guest operating system. Virtual machine memory over commitment. The situation is we have a host which has 12 gig of RAM, but then we've installed 3 virtual machines, and each virtual machine has been allocated 6 gig of RAM. 3 6s are 18. We don't have enough RAM. There's not enough RAM on this machine. This is called virtual machine memory over commitment. If you have more machines than you have RAM, that's called memory over commitment. And in that case, a virtual machine swap file, VSWP, is created. And a swap file is used when the ESXi host has run out of memory. Now here's how a swap file works. If you have enough RAM, great. But if you don't, the extra data spills over temporarily to the hard disk in what is called a swap file. This is also known as paging, and Windows calls this virtual memory, but VMware calls it a swap file. So ideally, swapping doesn't happen. Ideally, you don't run out of RAM. So memory reclamation techniques are technologies built into the ESXi host, built into the hypervisor that perform memory management, that efficiently utilize memory, and that reduce the probability that swapping will occur. So let's look at these different memory reclamation techniques which are part of the hypervisor. The first one is economize use of physical memory pages. Transparent page sharing is where pages with identical contents are stored only once. And I believe we've talked about that before when we talked about storage on the hard disk. Deallocate memory from one virtual machine for another. This is the ballooning mechanism, which we will talk about later in the course, but the ballooning mechanism is active when you're out of virtual memory. And what it does is it forces virtual machines to use their own paging area, and what it does is it frees up memory for other virtual machines. Memory compression. I expect you know what memory compression is on a hard disk. A zip file compresses files. You can compress an entire hard disk with Windows. With VMware, compression occurs in RAM, and the purpose of that is to free up memory. More efficient utilization of memory. And then if we are out of memory, SSD, solid state drive swapping. Well, we already discussed what swapping is. When you run out of data in RAM, when you run out of RAM, the data can spill over to the hard disk, and that's called swapping. Well, SSD, solid state drive, is essentially swapping to a USB drive. And the advantage of that is a USB drive, a solid state drive, has no moving parts and is faster than a hard disk. And then if we really do run out of memory, which we hope doesn't happen, then what happens is that is called swapping or paging, where the extra memory, the excess memory in RAM spills over to the hard disk, and the hard disk emulates memory, and that's not a good thing because the system performs slowly. So if we do run out of RAM, the swap file will take care of us, but ideally we have enough RAM, and that doesn't happen because when swapping occurs, then the system performs poorly. Virtual symmetric multiprocessing. Before we look at virtual symmetric multiprocessing, let's just review what's meant by symmetric multiprocessing. Symmetric multiprocessing means you have multiple CPUs. It means you have multiple CPU sockets on the motherboard. Here's a motherboard with two sockets. For two CPUs, they call that SMP, Symmetric Multiprocessing. Now, I expect you know what a dual-core processor is. Single-core processors are where you have a single microprocessor, but a dual-core microprocessor is where you have two CPUs on one single chip. Dual-core processor. So, virtual symmetric multiprocessing has the following characteristics. Now, you could have an ESXi host which had just one processor and just one core, or you could have a host that has one processor and two cores, or a host that has two processors and two cores, or you could have a host which has two processors, and each processor is a quad-core processor. And that is considered by VMware to be 8 virtual CPUs. Two processors, each of which is a quad processor, is considered to be 8 virtual CPUs. So when you create a virtual machine and you assign processors, you can specify the number. Previously, we created a virtual machine, and when we created the virtual machine, we allocated virtual CPUs. So you can see we could allocate 1, 2, 3, 4, 5, up to 8 virtual CPUs to this virtual machine. Why? Because the host has two processors, and each processor is a quad-core processor. Hyper-threading. Hyper-threading enables a core to execute two threads or sets of instructions at the same time. To enable hyper-threading, one, verify that the operating system supports hyper-threading, and then enable hyper-threading in the system BIOS, and then ensure that hyper-threading is in the ESXi host is turned on. CPU load balancing. The hypervisor is the program that runs the ESXi host. And the hypervisor will load balance multiple virtual machines across multiple logical CPUs. The hypervisor performs load balancing of multiple virtual machines across multiple virtual CPUs. So that concludes lesson 1, which was just a general overview of memory concepts. Now let's get a little more specific and move to lesson 2, which is resource controls. There are various systems for optimizing virtual machine resource use. Now, some of these systems are built into the VM kernel, and we really don't need to do anything. They're just as part of the operating system. We just discussed them. Hyper-threading, load balancing, transparent page sharing, memory compression, and swap files. And then there are other methods for optimizing the virtual machine which are configured by the virtual machine creator, such as assigning enough virtual CPUs. the more virtual CPUs you have, the more processing power the virtual machine will have. Assigning sufficient memory and in storing the virtual machine on a high-speed disk or data store, and implementing network interface card teaming. So that is for systems which are being set up. But we are focusing on administrating a system which is currently running. And this is what we will focus on. Once the system is up and running, we can use limits, reservations, and share allocations to optimize virtual machine resource utilization. So that's what we're going to do on this section. Resource allocation. The resources to allocate are the processor and memory. And the methods of allocation are using shares, reservations, and limits. So let's look at those. Start out with a resource allocation example. The host, ESXi host, has 8 CPUs. The first virtual machine takes 4 CPUs, and the second virtual machine takes 4 CPUs. No problem. That's fine. There is no resource conflict there. But now let's look at an example of a resource conflict. In this example, the host has 8 CPUs, but I have 3 virtual machines, and each virtual machine has been assigned 4 CPUs. Now, by default, they will all get equal priority, and that's the job of the hypervisor, to balance the priority. But let's say we've got these 3 virtual machines, and one's a customer application, other's the employee file server, and other's the test server, and this is a real important virtual machine. So instead of having it only get 1/3 of the CPU utilization, I would like the customer application virtual machine to get a full 50% of the existing CPU utilization, and then the employee file server and the test server only get 25% each. Now, by default, they're going to be a third, a third, and a third. So let's see what we can do to reconfigure the system such that the customer application virtual machine will get 50% of CPU resources. And this is called allocating shares. Now, the definition of a share in business is a part ownership of a business. If I have 200 shares in a business and you have 100 shares of the same business, that means I own 2/3 of that business. Now, in virtualization, shares refer to allocation of resources, not to a shared folder, which is something you're probably familiar with in Windows. So what we're going to do is we're going to assign shares, and shares are relative numbers. And if we assign the customer application 2,000 shares, the employee file server 1,000 shares, and the test server 1,000 shares, then that will be giving the customer application virtual machine 50% utilization of the CPUs in the ESXi host. So let's allocate those shares. Log into the ESXi host, and here are the 3 virtual machines. So we want to make it 2,000, 1,000, and 1,000. So if I right-click on the customer application virtual machine 1, select edits, I select the middle tab that says resources, and right now, by default, it has 1,000 shares. In other words, it's equal for all 3. So what I'm going to do is select the drop-down and assign 2,000 shares to that customer application virtual machine. 2,000 shares, fine. Click on OK. Now if I go to the employee file server and select Edit Settings and select the Resources tab, I can see that it's already set at 1,000 shares, so I don't need to change that. And then if I go down to the test server virtual machine 3 and look at Edit Settings, I can also see that the shares are set to be 1,000. So by assigning a higher number of shares to the customer application server gives it 50% of CPU resources instead of 1/3. By assigning 2,000 shares to the customer application and 1,000 shares to the employee file server and test server virtual machines, that gives 50% utilization to the customer application virtual machine. The definition of a share: in business, it's a part ownership of the business, and in virtualization, it's a higher or lower priority to a resource. Don't mix it up with the shared folder on a Windows computer. Allocating resources at different levels. You can allocate shares per virtual machine, but if you have a large number of virtual machines, you might want to use resource pools. Group the virtual machines together and then allocate resources to the resource pools, and then allocate resources to the virtual machines within the resource pools. And this takes us to lesson 3, resource pools. Log into the vSphere client, and there's a pool right there, and the definition says resource pools can be used to hierarchically partition available CPU and memory resources of a standalone host or a cluster. So let's do it. If we look at resource pool attributes, we can see resource pools control the same variables that we could control on an individual virtual machine, and those are shares, but now we're setting shares on the entire pool, which is a group of virtual machines. We can also set reservations, and we can also set limitations. So let's look at those resource pool attributes. Now let's just do a bit of a review here. I've got 2 simply virtual machines. We're not at pools yet. And one virtual machine is more important than other. The production virtual machine is more important than the test virtual machine. So what I'll do is I will assign shares of the test virtual machine of 1,000, and then I will send shares to the production, assign shares to the production virtual machine of 2,000, and just like in the previous exercise, this individual virtual machine now gets 2/3 of the resources. This individual virtual machine gets 1/3 of the resources. So that's just per virtual machine. But we want to use resource pools. The resource pools, when you have a large number of virtual machines, you use a resource pool. Group the virtual machines in the resource pool. In this example, we will have 4 virtual machines which are in 2 different departments, and one department has higher priority than the other. So one resource pool is one department. So we've got 2 engineering pools here. Now a resource pool is just a container. It's kind of like a folder. It's used to group virtual machines together. So I go to the engineering pool and give that CPU shares of 1,000, and the finance pool and give it CPU shares of 2,000, and just as we previously discussed, this pool gets 1/3 of CPU resources. This pool gets 2/3 of CPU resources. Okay, now let's go into the engineering pool. Within the engineering pool, there are 2 virtual machines, and one virtual machine is more important than the other. So the production virtual machine will get 2,000 shares of the engineering pool, and the engineering test virtual machine will get 1,000 shares of the engineering pool. So the engineering test virtual machine gets 1/3 of the engineering pool, which gets 1/3 of the CPU resources on the ESXi host. Now let's turn our attention to the finance pool. The finance pool has 2 virtual machines. One of those virtual machines is more important. So that virtual machine will get 2,000 shares of the finance pool, and the other virtual machine will get 1,000 shares of the finance pool. So if we look at the finance production virtual machine, if it has 2,000 shares, then it's getting 2/3 of the resources of the finance pool, which is getting 2/3 of the resources of the ESXi host. So here's how it would break down. The finance production virtual machine, which gets 2/3 of the finance pool, which gets 2/3 of the ESXi host, that virtual machine gets a full 45% of the entire ESXi host. Conversely, at the other end of the spectrum, the engineering test virtual machine, which just gets 1/3 of the engineering pool, which has 1/3 of the ESXi host resources, that virtual machine only gets 11% of the entire resources on the ESXi host. So let's do it. We'll give the resource pool 2/3 and resource pool 1 2/3 and resource pool 2 1/3. So we're assuming that pool number 1 is a higher priority pool. In other words, pool number 1 is going to be the same as the finance pool. Let's do it. What we will do is give 8,000 shares to pool 1 and 4,000 shares to pool 2. Remember, these are relative numbers, and in this case it's a 2-to-1 ratio. So let's go to the ESXi host, right click and select new resource pool, and I will give it a name. I will call it pool 1. Fine, click on OK. Now you can see there are two VApps which are not grouped in any pool. So I will drag and drop both of those VApps, business VApps, and I will drag and drop them both in pool 1. Now I will create a pool 2. Go to the ESXi host, right click, select virtual pool, select resource pool, and I will call this one pool 2, followed by OK. So now I have 2 pools. Now let's assign different resources to the pool, different shares to the pool. So I will go to pool 1, right click and select edit settings. And under shares, the default share is 4,000. So I'll select the drop down and I will select high, and that assigns 8,000 shares to pool number 1. Click on OK. Then I'll go to pool number 2, right click, select edit settings, and under shares, well, you can see normal is already 4,000, so I don't really need to change pool number 2. So 8,000 and 4,000. So this pool will get 2/3 of all CPU utilization on this ESXi host, and the pool number 2 will get 1/3. And if we didn't configure it this way, it would be 50-50. Resource pools group virtual machines and allocate resources. Now let's turn our attention to reservations. If there are many virtual machines running, a reservation guarantees at least a minimum amount of CPU utilization to a virtual machine. It guarantees a certain amount of CPU utilization to an individual virtual machine. So we'll take the customer application server virtual machine. Right click on that guy, select edit settings, and under resources, okay, we've already done talking about shares. Now we will look at reservations. Now there are no reservations. So if I slide the slider bar to the far right, I can have all of the CPU resources on this ESXi host assigned to this one virtual machine. So that would be reserving all CPU resources on the ESXi host for this virtual machine, and I don't think that's a good idea. How do you get 4,000 megahertz out of that? We've got 4 CPUs, and each CPU runs at 2 gigahertz. So it's 8 gig right here. 4 CPUs, each one runs at 2 gigahertz. So I won't use that. I will slide it down here And I slid reservations down so it's guaranteed at least 1 gigahertz. So at least that much will be available to it. And this is important if there are other virtual machines running. A reservation guarantees a minimum amount of CPU utilization to a virtual machine. That's a reservation. Now let's turn our attention to limitations. A resource hog is an application that takes an excessive amount of memory. And we can use limitations to prevent one virtual machine from consuming all available resources. Let's go to our virtual machine, right-click, select Edit Settings, under Resources, under Limitations. I will clear the checkbox that says Unlimited. And now the limit is already at the max, so that's not a limit at all. So I will slide the slider bar down, and now it has limited this virtual machine, so it will not take all of the resources on this ESXi host. At most, it'll take only 50% of the resources on this ESXi host. And I will click on OK. Limitations prevent one virtual machine from consuming all available resources. Limitations can be set per CPU, limitations can be set per memory as well. So, resource allocation. Reservations guarantee a certain amount of resources for a virtual machine. Limitations prevent a virtual machine from gobbling up all of the resources from everybody else. And shares are used to proportionally distribute resources when certain virtual machines are more important than others. Reservations make sure that the virtual machine has something. Limitations make sure a virtual machine doesn't take it away from everybody else. And shares is to proportionally divide the resources if there are insufficient resources. If there are sufficient resources, then we don't have to worry about shares. Resource allocation can apply to CPU and it can apply to memory. And most of my examples have been from CPU, but the same thing applies for memory. If I go into my resource pool and I click on Edit Settings, for CPU resources I can specify the shares of CPU resources, I can specify reservations, and I can specify the limit. Well, those same three variables also apply to memory resources. I can specify the memory resources, the shares, normal, high, or low. I can specify the memory reservations, and I can specify the limit, and the purpose of having a limit is to prevent one virtual machine from gobbling up all of the available memory so there won't be any left for anybody else. Resource allocation is made up of reservations, limitations, and shares. It can be applied to CPU, it can be applied to memory. It can be configured per virtual machine, or it can be configured per resource pool. And this concludes part 1 of Module 10, Resource Management and Monitoring.